X dollars on advertising. We are given that right now, in the current week, we're spending $2,000 on advertising. Those costs are increasing at a rate of $150 per week. So if the advertising costs are going up at $150 per week, what are my sales doing? Are they increasing or are they decreasing? Understand the question? So can we write down maybe what we're given or what we want? Can you interpret this? Maybe we start with what we want. What is the rate of increase or decrease of sales per week? Sales per week. Times in there. DS dt is what we want. We want the rate of change in sales per week. So ds dt is what we want. So I'm going to put a question mark there. Do we know anything about any rates? Are we giving any other derivatives in this?
dx over dt, which is the 2,000.
So if current advertising costs are, we have current advertising costs are 2,000, right, per week, and they are increasing at a rate of $150 per week. I've underlined two things there. Which of those is a derivative and which of them is not? And how can you tell?
Rate isn't a derivative. Rate is a derivative.
The rate is the one that's the derivative. Okay? So that's the key word right there. They're increasing at a rate of $150 per week, right? Yes?
For example, if it said it was decreasing, we could just put it negative.
Yes, very good. If this was saying decreasing at a rate of 150, we would use negative 150, all right? But it's increasing, so we treat it as positive.
So
I don't think any of the problems that I've come across in this book do decreasing, but yes, it would be negative.
So then it would be equals dx over dt would equal 150.
D what?
Dx over.
Yep, dx over dt would be 150.
150, I'm sorry.
Yep. Understand? Now, what about the 2,000? That does come into play here. That's x. So we want this at x is 2,000. All right. We would like to know the rate at which the sales are changing with respect to time at the moment that that the advertising cost is 2,000, and with the knowledge that the advertising cost is changing, increasing at $150 per week. Okay? What we're currently spending on advertising, the rate at which the advertising is going to go up, how does that impact our sales? Ready? What do we need now? We need an equation, right? That somehow connects these two things together, sales and x, and well, they gave it to us, right? So we get to take this equation and we need to do the derivative of this with respect to time. So let's do that. What is the derivative of, well, let me write it all down. We're taking derivative of the left side with respect to time, the derivative of the right side with respect to time. Okay, what is the derivative of s with respect to t? ds dt, right? That's the left side. And again, we're happy to see it because it's what we're trying to solve for. All right, on the right side, we have 50,000 and then minus something, right? So we can do these separately. What's the derivative of 50,000? 0. So that's gone. Now we have minus 20,000 attached to this thing, right? This right here, you should recognize as an exponential function. We took derivatives of exponentials in the past. But what happens with the negative 20,000? It's going to come down with it, all right? Because it's not like the 50,000. It's not by itself. It's attached to something. So it must come down for the ride. Negative 20,000 is here. Now, times, what is the derivative of e raised to anything? Itself, okay? So we're going to write down e raised to negative 0.0004x, right? And we're not done. We're not done. Now we have to take the derivative, and we're going to multiply. So this is something, right? We're going to multiply that by what? The derivative of what's up here, right? The derivative of what's up here. Let me remind you, if I asked you back when we first were doing derivatives of exponential functions, if I asked you to take the derivative of this, you were supposed to say, well, it's itself times the derivative of what's here, which you would have put 2x plus 1. Does that look familiar? Okay? We're doing that exact thing right here. We're saying, what's the derivative of e to something? Well, itself. And now the derivative of what's up here. Okay? Now, when you take derivative of what's up here, this negative 0.004, that's like a constant, right? So it's going to come along. So I'm going to put negative 0.0004, and then I need to take the derivative of x. Dx dt, right? What are you differentiating with respect to? T. So the derivative of x there is dx dt. And that's multiplication right there. See, back here, yes, the derivative of x was 1 because we hadn't talked about implicit differentiation yet. We hadn't talked about differentiating with respect to variables other than x. Does that make sense that this is the derivative? Okay, this is what we want to know. So I'm happy to see that. Everything else here up. Do I know what x is? Yes, 2,000. Do I know dx dt? Yes, it's 150. So I'm just going to plug numbers in now, and I'm going to need my calculator. So I'm going to be doing on my calculator negative 20,000 e to the negative 0.0004 times x, which was 2,000, times negative 0.0004 times 150. All right. So you need to now make sure you can do this on your calculator, all right? You do not want to be here next Tuesday trying this on your calculator for the first time. So if I were doing this, what I would do is on my calculator try and figure out what this is first. But everyone's calculators are a little different, so this is why you need to practice before. Let's go ahead and get the answer, and then let's see if you can get that answer or not. I'm going to do this in pieces. This just right here on my calculator, just that piece, is 0.449328.9. I'll stop there. Okay, so that's that piece. Of course, this is 20,000. And then this right here, on my calculator, this piece is just negative 0.06. So I take all those and multiply them together. And I get negative 539.19. And you might have some rounding error there. It's okay. If you're close, that's good. What? I forgot what? Oh, there was a negative out here. Oops, I forgot the negative. Yes. All right. That should be positive. I was hoping it would be negative because I wanted our sales to be dropping. But that's what it would have meant, right? It would have meant that our sales were dropping. But in this case, I guess they want this store to make money. So what we have is ds dt should be $539.19, because sales is measured in dollars, over time, which is per week. So, you know, if this is your company, you're like, hey, look, we're spending $2,000 on advertising right now, right? This company wants to charge us now $150 more a week, right? But what we should expect with that increase in, it's almost like an investment. You're putting more into advertising, but you're also getting more return in sales. So we're putting in 150 more a week, but we're gaining 539 more in sales. So it's probably okay that the cost went up.
Any questions like this you want us answering, like sentences?
Well, what the most I would want for this, because it says, what is the rate of increase or decrease of sales per week? If you write this down, you have answered it with no words. That's okay. That is, I read that as $539.19 per week. But if you want to write it in words, you can. Okay, so on Thursday we will come in and review, all right? And then Tuesday we'll have our test. So y'all have a good day. Try your homework problems for this section. They're very similar to what we did today. All right? Have a good one.
I stand you my.
Yes, I did see that, but thank you for the hard copy. I appreciate that.